Welcome to Unit 3, Day 6 notes. Two perhaps positives of the day. This will be the last set of notes that you take on slope-intercept form. Woohoo! And we're also going to take a break from graphs today and strictly look at tables of values that have a list of ordered pairs that are on a line. And from a table of values, we're going to go ahead and write the equation of the line in slope-intercept form. First order of business, if you guys would cross out Unit 3, Day 5 and write Unit 3, Day 6. We did push this back a day. And then also if you'd write the objective for these notes and for the day. I want you to be able to write the equation of a line in slope-intercept form, but I'm not going to write that, given a table. So we will look at equations of lines in slope-intercept form today, y equals mx plus b, but instead of looking at the rise and run for your slope, we're going to interpret it slightly differently so that we can read it from a table. We'll also look for the b just a little differently or apply our current understanding to be able to get it from a table. If you take a look at the question on the left, it says, how can you think of slope looking at the x and y values of points on the line? And that word slope, it should resonate with you that we look at slope as m, and we've called that up till now rise over run. And if you remember my questions over the past few days, I've asked you what does rise go with, which variable, and you've said y hopefully. And then that means the run goes with x. You got to stand before you can run. You have to go up and down before you can go left and right. And if you're looking at that triangle symbol, that should look somewhat familiar. That means delta, or represents delta, and that means change in. So we read it delta y, and it means change in y. And so when we're looking at the change in y over the change in x, we're really looking for the difference of the y values over the difference of the x values. So let's go ahead and look at that from the table. If you take a look at your y values, we're going from 7 to 9, 9 to 11, and 11 to 13. Every time we're increasing the y value by 2. And so our delta y, aka our rise, is going to be 2. Let's do the same thing with our run. If you take a look at how much the run is going up from 0 to 2, 2 to 4, 4 to 6, it's a constant change of 2. So our delta x, aka our run, is going to be 2. So now I'll ask you to revisit rise over run being the same as delta y over delta x, and we can write a ratio of the values that we just got. So we can say delta y over delta x, our rise over our run, our slope, is 2 over 2. And you always want to simplify your slope, so I'm going to just say that that is 1. The second part then is to identify the y-intercept. And if you look at that question on the right, it says, what is the x value of the y-intercept? And if I were to draw a quick sketch of a graph, we are always moving from the origin up or down to get that point on the y-axis. And if you remember, I've asked you to write this as an ordered pair, 0, b, b being the y-intercept. And so what is the x value when looking at the y-intercept? It's 0, and then comma, whatever the y-intercept is. If you take a look at the table and you look for that 0 in the x column, you'll see that the corresponding y is 7. That 7 is our b. And so now we have both parts because we have our m is 1, and we have our b is 7. We can complete the equation y equals mx plus b. Y equals, instead of m, I'm going to plug in the m, 1, x, and then plus we have 7 for our b. And that's the equation of the line strictly read from a table. Let's go ahead and look at a couple more examples. So we're going to do the same thing and take a look at this table. First of all, if we want to identify the change in y over the change in x, we need to look at the pattern from y to y value, and we need to look for the pattern from x to x value. And so if you look in the y column, our delta y, our change in y, from 11 to 15, 15 to 19, 19 to 23, that's going to be a positive 4. And if I do the same for my delta x and look at the change in x from 0 to 1, 1 to 2, 2 to 3, I get 1. That means that my delta y over delta x, my change in y over change in x, my slope is 4 over 1, which can be just written as 4. Then let's go ahead and look for that y-intercept. If you remember from above, our y-intercept will always have the x-coordinate 0 because we're not moving left or right, we're only moving up or down. And if you look at what value goes with the 0, we have that corresponds to 11. So that's my b. And now I can complete the form y equals mx plus b. I have y equals, my m is going to be the 4, x, and then my 11 is positive, so it'll stay plus 11. If you want to pause the video, try out the second example before we look at the last set of problems, I would recommend that you pause now. And welcome back. Let's go ahead and take a look and see how this example went or how it's going to go. So, delta y, change in y, my rise. If you notice, it's dropping this time from 12 to 9, 9 to 6, 6 to 3. That means that my delta y is negative 3. And if you take a look at your delta x, the change in x from negative 2 to 0, 0 to 2, 2 to 4, we are going up by 2. And so my rise over run, my delta y over delta x, my change in y over x is negative 3 over 2. Leave that as rise over run. Do not write that as a decimal. Do not write that as a mixed number. Then let's look for that 0 in the x-coordinates so we know what the y-intercept is. And if you haven't already called it out, it is 0, 9. And so our equation is y equals, the slope is negative 3 over 2, so leave it in that form. X, I got to make sure I have my xy in there for my ordered pairs on the line, and then plus 9. Not too bad. We're looking at rise over run still for slope, but from a table, and then we're looking at that y-intercept, strictly looking for ordered pairs. And so now I'm going to ask you to skip to the bottom of the notes to answer the question based off of these two examples. And if you look down there, it says, how can you test the accuracy of your equations? How do we know that y equals 4x plus 11 really does work? And if you remember from the notes that we did just yesterday, I asked you guys to plug in some ordered pairs to see that they work when you test them out. And so I'd like to do the same thing here. If we rewrite the equation y equals 4x plus 11, I'd ask you to pick any of the ordered pairs, maybe not the y-intercept, but any of the other ordered pairs and see that they work, just to make it a little bit more interesting. And so I'm going to plug in the ordered pair. Let's go with maybe just 115. It's pretty easy to see. And so what I want to do is I want to test that ordered pair, and I want to see, does 15 for my y-coordinate equal, and then if I have 4 times the x-coordinate, which is 1, plus 11. And if you do 4 times 1, that's 4, plus 11 is 15. That does equal the 15, and I've solved the equation correctly because I got an ordered pair to test true. Same thing with the second equation. So if I look at y equals negative 3 halves x plus 9, I could plug in any ordered pair. Again, maybe not the y-intercept because that would be pretty straightforward. You would get 9. But if we plug in any other ordered pair, we should get that the left side, the y value, equals whatever happens to the x. So I'm going to go ahead and pick, let's go with 4, 3. And so I want to get 3 for my y value. And does that equal negative 3 over 2 times 4 over 1 plus 9? And so if you look at your values there, if we multiply across in our fractions, negative 3 times 4 is negative 12, over 2 is negative 6, and then negative 6 plus 9 is 3. So again, I've tested that this one works out correctly. And so stay there with me. We're going to look at just one more example where if I don't give you a table, but I give you 2 ordered pairs, how can you figure out the slope of the line that passes through the following points? But what's the difference really? I'm still wanting to look at the change in y over the change in x. So if it helps you, go ahead and, looking at example 2, write an x column and write a y column and just be sure that your ordered pairs align. So I can do negative 4 and 3 as my first ordered pair and negative 10 and 9 as my second ordered pair. And really we only need 2 points on a line to figure out the slope or the equation to graph the line. So if I look from 3 to 9, I'm going to get that that's going up by 6 for my delta y. And if I look from negative 4 to negative 10, that's actually going down by 6. Negative 4 to negative 10, you have to add a negative 6, you have to subtract 6 to get further negative. And so if I write that ratio of delta y to delta x, I'm going to get 6 over negative 6. And as I've stated before, we're going to go ahead and simplify that to negative 1. Another way of looking at this is subtracting your x's and subtracting your y's. So I'm going to show it just a little bit differently on the right-hand problem, example B. And so when I'm talking about that change in y, I'm asking you to look at the difference in the x values and the y values to get your slope. And so what if I call my first order pair x, y, because those are the coordinates, and then x, y. I could take the y's and subtract them from each other, and then the x's and subtract them from each other. And I'll get the difference or the change in the y's and the change in the x's. I just need to be sure that I do them in the same order. So if I take the first y coordinate, which is -1, and I subtract -5, I need to be sure that I take the first x coordinate and subtract 0, the second x coordinate. I could also have done the second y coordinate, -5 minus a -1, but then I would have had to do my 0 minus 8 to be sure that they align. You can go ahead and set it up like you did the previous example if it makes sense to look at a table to get slope, look at the change in y and x that way. But I'm going to go ahead and finish it. So if I do -1 minus a negative, that's plus a +5, and that's 4. 8 minus 0 is 8. And if I simplify, I can divide both the numerator and denominator by 4. I get 1/2. And then a bonus question would be, don't only write the slope of the line, but I think that you could write the equation of the line. And if you look closely at the ordered pairs that I gave you, one of them is the y-intercept, 0, -5. So I've got my b, and then I just asked you to get the m by subtracting y's over x's or doing the table like we did before. And so the equation for this line would be y equals 1/2 for the slope, x, and then that b is a -5, so either -5 or plus -5, either of those will work. And that's the equation of that line. A little harder to do if you don't have the y-intercept given to you, but definitely doable in this example. All right, so that's enough notes, I think, on writing equations from tables. Either look at the change in y along the table, or look for the change in y by actually subtracting y values and then doing the same for x values. Go ahead and try the day 6 assignment.